Okay, so let's go ahead and talk about special class member functions as well as the new default and delete keywords. So in C++, of course, the compiler will generate defaults for you for several kinds of class member functions, the so-called special member functions. So, for example, you've probably written a struct or a class before which is comprised only of member variables and not any member functions. So a very common thing to do, maybe you just have a vector struct, just organizing some floats there, x, y, z, but you don't really have any member functions. And chances are you probably didn't want to go out and implement a constructor or a destructor that doesn't do anything because it doesn't need to. So the compiler, if you omit the constructor and destructor, the compiler will generate defaults for you, and it's not afraid to do that. But there are conditions for these special member functions to be generated by the compiler. So, namely for the default constructor, which is the constructor taking no arguments, no other constructor can be defined by the user. And it's important to note that this is because maybe you have a class where you want it to be constructible but only with some mandatory arguments. So maybe you have a game engine structure where you pass it a screen device context or something along those lines, and it requires that to be able to construct itself. So if you have any other constructor present, the compiler will say maybe he doesn't want a default constructor, so I'll leave it out and let him implement that. In that same vein, we have some conditions for the copy constructor. So the copy constructor will only be generated by the compiler if no copy constructor or move constructor is defined. And similarly, we have some conditions for the copy assignment operator and the destructor as well. So in C++ 11, of course, we have move constructors and move assignment operators thanks to move semantics. So the compiler will generate these too. C++ 11 mandates that compilers generate defaults in certain situations. And the list of conditions is actually pretty long for move constructors and move assignment operators. So you cannot have a copy constructor, copy assignment operator, move constructor, move assignment operator, or a destructor for the compiler to generate a move constructor and a move assignment operator. So let's talk about the default and delete keywords. So draw your attention to this struct right here. So this is a templated struct called DCDC. Now DCDC has a member variable m, okay, and it has a copy constructor, okay, which just copy constructs m with the m variable of the other structure. So notice that the condition for the compiler to generate a default constructor is actually not met here. So let's go back to the slide, and you'll note that the condition here is that no other constructor can be defined. No user-defined constructor can be present. So the compiler will not generate a default constructor. But we can force the compiler to generate a default constructor by using the default keyword. So the default keyword says, I know I've not met the condition for you to generate this, but generate it anyway. So it's very useful if you have a structure where you've defined some other constructor, and that constructor is very useful for certain situations where you'd like to instantiate with those arguments, but you'd also like to be able to default construct. But if you go ahead and write out your default constructor, it's going to be very long, and you're just going to be default constructing each member variable. So you'd rather not write it all out yourself. You can just write equals default, and the compiler will generate that default for you. In that same vein, we also have the delete keyword. which kind of indicates the opposite of default. So what delete indicates is it says, okay, don't generate a default function even though you've met the condition for it. So we have this struct here called noCopy. NoCopy has a default constructor which just does nothing. And we are indicating to the compiler that the default copy constructor and the copy assignment operator should be deleted. So the compiler should not generate defaults for those functions. So it can neither be copy constructed nor copy assigned. It is important to note, though, that this struct can be moved. The compiler will generate move constructors and a move assignment operator for this struct. So you can see here the conditions are that no copy constructor, no copy assignment operator, etc., etc. And we have met all of those conditions, so the compiler will generate the move semantics functions for this structure. So it will be movable. It will be movable. So all in all, very useful default and delete, because now it allows you to control the generation of these default member functions.